Hello and welcome to the first episode of JaRu, Effective JaRu to be precise, which is basically me reading the Effective Java book and then trying to port the concepts shown here to ideally idiomatic Rust. And of course, lots of commentary of mine that will probably be very opinionated too, just because, I managed to not get myself involved with Java for many years now, and I lived happily. And now I do have to learn Java, and I have the feeling that I will be missing so much because I always compare to other languages, like maybe even Go, or obviously a lot of Rust. And I don't know. I will see. I dislike many things, and this is my personal opinion, of course, and I have no Java experience whatsoever, so I am just learning Java by looking at the examples and looking at actual code. So I'm not going to basically read the reference manual really, because I don't think that will be required to learn what this will be about. Because Java seems to be more like a C++ with garbage collection and, a certain and a bit more wordiness. Okay, so the goal of this episode will be to basically do the item 1 of the chapter 2, which deals with creating and destroying objects. So basically it tells you that, you have constructors in Java, of course, the standard ones that you know from C++, for instance. But you can also have static factory methods, which are one way to name your constructor, right? It's really just that. And of course, you can have many different static methods that produce an object of the desired type, which allows you to basically document more easily what kind of object you are getting. You could even have various implementations that you create under the hood that are all corresponding to a particular interface that you define. All this works, all this is in use. And as a more complex example, which I would call kind of dynamic constructors, is this pattern where you have a provider, which is nothing else but a closure basically that returns an object that implements a certain interface or a certain service, as they call it here. I might mix up terms here. Interfaces are a valid term, obviously, in Java. In Rust, you would return things that implement a trait, and this is really what I want to show off here, because even in this code, plenty of stuff is super implicit, like, hey, by the way, all this stuff is heap allocated, right? How else would it work? Because, an interface is really nothing else but some way of having an actual implementation that is behind some virtual method table or something, depending on how this is implemented in Java, of course. But this is how it is. Under the hood in some way. This is the concept behind that, right? So let's start with a Rust implementation. I've prepared a folder here, so I am in Effective Java Example Source Main Rust Chapter 2, and we might have a look at item 1 here. Let's see what we have. So we have a provider interface, which just is having one method that creates something. This is also, because Java is Java, it forces you to have a class all the time. So one public interface or a class, that's how I see it right now, per module. And then you can put these into packages where you have multiple classes. But basically it forces you to scale this across multiple files. If you want to or not, you have to do that. It forces a certain structure onto you. In Rust, you can obviously do the same thing, but you are free to do it, just to structure it however you like. So that's one major difference I see in the package system or the module system that you have here. So I'm just looking for a static constructor here. No, not really, but we will just show this off, maybe even here. So services, new instance. Okay, here we have a static constructor. So if you have new instance, you get a default provider, which I wonder, you probably have to register before this thing can work, huh? Yeah, so let's see, is this is private static. So these are static members. So basically it's a singleton mechanism, right? Kind of, because you will only have one of one of these in a running program. Something like this does not even exist in Rust, because ownership is so much more complicated with globally accessible data. If it's mutable as well, this thing is totally mutable. So yeah, in Rust you can't do that. Or you will have to protect it with mutexes and stuff. So we will see how we do that. I'm curious. But it's, yeah, let's see. So interestingly, if you say new instance, and you didn't register a default provider, this will throw. And if I get this right, an illegal argument exception is derived from, let's see if we can get documentation on this. For this reason, I have IntelliJ here because, it's the first one I open. I have NetBeans installed as well as Eclipse Mars. And IntelliJ is the first thing I open. It made a very good impression. And the only reason I want it is that I have auto-completion and all the fanciness and smartness of a super mature Java IDE that, I don't know shit about, basically. I really don't know it. I just use it as a tool to help me with everything. So what I want to check first, just for my own sake, can you give me the documentation on this? Find usages, no. Copy reference, go to, jump to declaration. Yeah, that could be something. Open on GitHub, interesting, GitHub is everywhere. I didn't know that. So, declaration. Let's see, do we see... Yeah, so it's a runtime exception, right? And runtime exceptions are unchecked. And that's important to know. This is why you don't have to say throws something here. And this is something general about Java error handling that I kind of dislike, because it's split into two worlds. You have checked exceptions and unchecked exceptions, and you always have to deal, if you wanted to catch this, you have no idea that this throws. And it can easily throw, I just don't register the default provider here and it will die on you. And you have no idea of knowing unless you study the code. Okay, checked exceptions are exactly for that, right? But what are you using? Are you using unchecked ones? If you're using checked ones, there's no question about it. But it's really, I'm totally, this kind of error handling is already... seems already broken to me, especially compared to Rust, only compared to Rust, to be honest, where this is totally impossible to get wrong. You will have to deal with the possibility of not getting a service because, we will have a look at the Rust implementation. So new instance is basically what we could call a default one. There is no default implementation here that we know of. So we have a test where we will do this stuff. So we have a default provider here. That is interesting. So it's an inline definition of a type, right? Is this that? I think so. So that's interesting. And what is this? This is a class now. That's implementing a. Okay, maybe let's look at the provider here. So maybe this is how you make providers, kind of, or how you implement these, huh? So this implements the provider interface. Then you just repeat the signature of the function that you want to implement. And then you actually then you actually implement a service inline. That's cool. That's kind of cool in a way. Even though right now it's difficult for me to read that correctly, but I think that's exactly what it is, like an inline implementation of two interfaces, which is cool. Kind of. So yeah, and you do this, with a few ones, and they just change their string to identify the different implementations. I think I should be able to run this. Run the main class here, and it says default service complementary service armed service, which is this thing, huh? Yeah, so it prints these, and we are done. Cool. So let's implement this. Okay, that was how many? That was 11 minutes just to show off what the Java world would do here, and now we see what we would do in the Rust world. So cargo new, I always want to do cargo new. I think it's cargo init. I always do the wrong thing here, so probably init is wrong. Item 02. Haha, see. Cargo new. Item 02. Nice, so we have a cargo toml. I don't care. And we should have a lib here that we can work with. Okay, so the test, I'm not sure. We might wanna give it a CFG test, and then put a test module around it. This is just to prevent compilation in release mode. It doesn't really matter for us, so probably I just shouldn't do it. But yeah, here we will test the instantiation of stuff, I suppose. So if I run cargo test on this, it should already run my test and say we are all good. And I only want to run the lib test, not the doc test. So now we see a little less here and less cluttered. Good. So yeah, let's build this class stuff here. So we have a provider trait, which, I know I'm not actually typing this, which will create a new instance of stuff. So we have a new service which returns a service, and actually returns a box service, because in order to abstract over a certain trait, which is service in this case, we obviously have to obviously have to box it, because otherwise we can't at compile time determine the size. And at compile time we have the size of the object, but if you want to work abstractly with it, without knowing what actual implementation is underneath, you need to put it onto the heap, which hides this information. It also removes the type, right? So this is what you would do, but in case you have a trait that really just has one method, this is a closure for us. And I wouldn't have a provider trait here because it doesn't matter at all. So in this implementation here, we are saying that toString must be implemented, right? And we can enforce this by saying every service must implement toString. And we could say something like std str toString. I'm not sure. No, where's that trait? I have to look it up. I use it rarely enough for toStr. Show me. Oh, std string toString. See, so that was my fault here. Use. Oh, damn it. So I'm already getting brain fucked here by switching from Java to Rust. And interestingly, because Rust is so different in terms of how it looks, and actually I prefer the way Rust looks over Java anytime, but I now have to think about it effectively. So yeah, sure, it's my first episode, my first session. My brain has to get used to it, so I apologize if I suck in everything I do. But that's how it will be for the next for the next days, weeks, hopefully not month. After 1 month, I think I should have handled it. Okay, so this is our service trait. It just enforces toString, and as you can see in Java. Let's go here to the service Java. It's not clear what we are actually doing because here there's nothing yet. We have an empty interface. But what we are actually interested in when you look at the implementation here is the toString override that is happening here. This seems to be something implicit to every object. But in Rust, I can put this onto that side. In Rust, this is... we can also disable this for more space. So in Rust, this is explicit, right? Because this is exactly what I expect from one of these implementations. They need to do toString now, which is pretty cool. And in a way, we could even leave out a service, obviously, because it's empty. But we could say put actual interface methods here. Yeah. So what else do we have? We have now we have this registry, basically. I would call it a registry, the services registry. And we can't, this is interesting because we don't have this public or this static stuff really. And if you had it, it's difficult to use because you have to protect it against everything. But I will try it anyway. Let's try it. But if you want to make this work, we definitely have to throw a bunch of mutexes in there. But in any case, we have a services structure that has a mapping of providers. So it maps a string to a constructor, and this constructor is just a function that you call to create a service. And this is what we have here, I guess. So how do they call it? Providers. Let's call it constructors. Let's call it providers, just to stick a bit closer to the example. And we have a hash map of strings too, and now it comes boxed. Let's see if I can make this happen. Boxed functions that return a boxed service, right? And this should be the definition of what I have here. Does it work? Did I mess? I mean, it doesn't work. It doesn't like it just now, and I wonder why. So let's fix this. I rarely actually do this kind of signature here, so I don't know. Maybe here we have a box fn, then we return a box. We close this. So there was a bracket missing. Good. So now at least syntactically it's correct. This is how that would be defined. Let's look at the Java version. Okay, here you don't have, this boxing is implicit after all, because all objects, everything but primitives, like plain old data types, are reference types, and reference types are by definition on the heap, so they're reference counted. And that's interesting as well, because you could ask, well, is it thread safe, this reference counting? And you would have to say, well, it must be thread safe, right? Because I don't think if you can specify if a type should be passed across threads or not. But this also means that basically everything has to be thread safe. So you use atomic counters, even though in some programs you probably just don't need them, huh? So that's another weirdness of Java, where it's, where to me it's by that definition is already broken, because you shouldn't enforce something, you shouldn't have to use something that you don't need. But maybe by that definition also Go is broken, and everything that has a garbage collector is kind of broken. If you wanted to have perfect efficiency, which is something that Rust actually offers. Okay, so that is providers. Then we have a default provider name. This is something we could put into the into a constant here. Default provider name, which is a static string, which shall be dev. There we go. So that is that. So as you can see, there is no such thing as class fields, class data members, or struct data members, right? It's always per instance. And anything else, you know, we could have a mutable static one here. This is possible, I think, but yeah, I wouldn't dare right now, but we should try at least to get that. So we have a default provider name that we might actually call default provider name. And in order to have a singleton, you would have to make a static mud services somehow, huh? How does that work? So it doesn't work at all, but I would like to make this work. Just, you know, let's see, because I think this could work. And then we assign it. Can we assign it? I mean, this probably doesn't work because it's calling non-constant. You know, this has to kind of run at the initialization of the program, and this is a problem if you have complex types like hash maps, which are heap located and stuff. So I don't think this works syntactically, but maybe it does. True. So mutable statics are not allowed to have constructors. See, so their function calls and statics are limited to struct and enum constructors. Yeah, which makes sense, because structs, constructors, basically you can just provide with static values, and we don't have that here, so that doesn't work. So in Rust you can't even do that. See, you have to create at runtime this instance and use it somehow. So I've seen this coming, to be honest. Let's see what happens if we don't make it mutable. Does it work then? No, because still we cannot. Oh, wait, then it would work. Cannot be shared safely. That's true. So what does it tell us? Let's dig in. So sync is not implemented. Whenever something is static, sync needs to be there because multiple threads can possibly access it at the same time. So note core ops fn box servers cannot be shared between threads safely. And yeah, let's see if we can make a thread safe here. What if we say it's a mutex, and we say mutex new and put a service in there, and then it's std sync mutex maybe? Okay. So send. So here it comes. No, wait, send is not implemented for type. Huh. So in order to get sent, you would have to put it into an arc. And I think then we can make all this work. Arc is an atomic reference counted thing, so that way you can safely use it in multiple threads, and you're sure that the lifetime is long enough, even though I would argue that the lifetime here should already be long enough anyway. Maybe I can enforce send, and if you do this, then it's unsafe. Unsafe impl send for services. Oh. Yeah, probably the syntax here is wrong. Let's see. Huh, but this works somehow. Let's roll that back. It's not unsafe. Requires an unsafe impl declaration. See? I thought so. And now statics are not allowed to have constructors. So now we basically got back to the original problem that we cannot call constructors during static initialization of our program state. This is something that can possibly be made work at compile time, because after all, the program at runtime has some sort of initialization stuff that happens. In C++, this can work, for instance, just because it's implemented, right? But let's just say right now everything has to be done statically here, and yeah, I don't know. I think this can work at some point, but right now it doesn't. Also, I don't think it leads to good anything. I mean, no, you know. So I think this in the moment we enforce the send implementation here, we wrap it into a mutex, we are actually safe, because this will be valid throughout the lifetime of the program. And I say, well, there is no issue in accessing this, but this is something it's unsafe to assume, because there could be certain conditions that arise anyway. So this is something you don't want, all this, you know, because it's hard to do that, and it's hard for good reason, because you shouldn't actually do it. So yeah, let's kick this out and try to get an instance of the service provider here. You can also look at the test version. So here, you know, this doesn't work for us. So we do a let mud services is services. We could just implement default here, because that will be just fine. So derive default, and now we can have a default service implementation here. So we have this registry. And now, by the way, here we have, right now I say, well, we always return a box service, but in fact, you know, we might just not have one, right? So this is an optional at best, or ideally, ideally it is a result. So I think, because the worst thing that will happen is that we do not have this a provider for that particular key, or a constructor for that particular key that is given to us. All we have to do here is to put an optional around it. All right. So this is kind of the structure, but where is our implementation? We need something here to work with. So we have register default provider, register provider, and in a way, you know, this default provider is something we always need when we want to get such a service here, right? Because without a default provider, I don't know. If there is something like a default provider, then it must be given. That's what I say. And if there is no such thing as default provider, you know, we can skip this. And I don't like this, that there is a special provider. But, you know, this to me looks like, well, this should always be there, right? Because if you say new instance, you expect to get the default thing. And, you know, in order to make this work, I say, listen, we have to adjust this. So in fact, there's no default one here, but there is new, and you have to provide a default implementation for this. So let's have it. We need a service implementation now. So we have a struct default service. It doesn't have any state. Oh yeah, actually it's like this. Then we can get away with just specifying it. And when we say we would like to implement service for default service, and this thing must have a toString implementation as well. Otherwise, this wouldn't work. So we will see how far we get with that. I'm curious myself, but we definitely have to provide that default service here. And actually we have to provide a constructor that creates a default service. And yeah, I think this would be as easy as default service. Yeah, we just create it like this, right? This is our no, wait, actually I'm wrong here, because we look up a constructor, and if we have a constructor, we expect it to return a service. That's all right. But whenever somebody asks us to construct something by name, then we have a result type. But we haven't even specified the interface yet of the services trait. So this is what we would have to do, right? And I think because it's empty, all we have to do to get an instance of this is that. So this is more like it. And of course we don't even have that thing yet, and I would like to remove this conditional compilation so that when I hit save, it will test this, it will run this code or compile this code and tell me what's wrong with it. Because what's definitely wrong is that I'm calling a type method, or a struct method, I call it type methods as opposed to instance methods, which is supposed to create a new service thing. So let's have impl services, and we have a function new that takes a default provider. Provider which is of any type that is a provider that is a provider which is supposed to implement this, right? So we expect a closure here that returns a box service instance. So this is that. The cool thing is that this actually allows us. Oh wait, did I specify that correctly? I think I don't like this. Let's use where here. So that makes it easier to read. Where p is fn is a function that returns a box service. And of course the return value here is a new services instance. And this is that, right? So that would be the declaration in Rust. So that's a generic type method, because we can pass in any kind of function here, and it will just do the right thing. It will take ownership of that though, right? So let's see how far we get with that. So now within this, we can instantiate our item here, which takes a hash map new. So that's our instance, I say. We return the instance. So notice the non-explicit return, which is super useful in every which way. It makes it so much more readable, in fact. Hard to believe, but it is like that. Once you've used it, you don't want to miss that anymore. Having to specify return all the time, which you can, of course, is an annoyance in many situations. So we have a new service provider here, and now all we want to do is to insert this default provider into our map with the default provider name. So I think, if I'm not totally mistaken, it should be something like providers insert, and then we give it a key and value, right? And the key could probably be just the default provider name. That might work, because that's obviously not a string, but I think this can do the conversion for me, but we'll see about that. And then we give it the default provider here, and we should be done. Let's see. So that would be the implementation in theory, and this should possibly work. But who knows? So the trait display is not implemented for the type default service, which is basically why is this required, you could ask. I think it has something to do with the toString thing. So if we remove this, we should be better. So let's remove it for now and then work on these other issues until we are there. So here, it's expected a string that it wants to own, got a static str, a static string. So yes, we have to convert this here to string, or to owned does the same thing in this case. And now, default provider, sure, it wants a boxed one, but it found parameter p, it didn't even care about the type in there. So I think we should be good if we just say box new, and this basically puts that function into a box and moves it onto the heap. The parameter type p may not live long enough. Okay, interesting. So to get that, I think I can do this plus static, and now it works. Is never used, excuse me. Oh yeah, because we want to run the tests here. So we can build it now, but this part here is the test that wasn't built previously, apparently. So apparently, I didn't know that. The tests are never built unless you test it. Cool. So the CFG testing to have conditional compilation doesn't seem to be required at all. Yeah, that's nice, I think. Kinda. Okay, so now, found a default service, expected a boxed service because we have to return a boxed service, right? And that's important because otherwise we couldn't make this call at all. After all, the actual implementation should be hidden, so stuff needs to be boxed. Here we go. So now we have a constructor, and this actually works. So now we have the technical stuff right, and can say, well, I really want toString here. And now we have to implement toString for our default service, because after all, this is what's service requires toString. So let's just try it. Impl toString for default service. Then we have an fn toString that takes, I guess, a borrow of yourself and returns a heap allocated string. And what we do here is we just say, we say the same thing that they do. It's default service. And in a way, we don't need a real heap allocated string here. We just need an asref str, which is more efficient. So let's do it, because this string is heap allocated, and in Rust you wouldn't do that even if you don't need it, right? So if you don't need it, we don't use it. So let's not do this then. Then it's asref str. Let's see if we can specify this. Asref should be in the prelude, so it's automatically there, even though we don't do it, we don't import it or use it explicitly. This is what the compiler does for us, and it's well documented, because if you want to know what's in the prelude, you can basically just say, well, show me the prelude. It's just a module that it imports, basically. And that's pretty cool. So anyway, we want to have as ref string. And now if you want to implement this, we can say as ref str for default service. And then it's as ref. And yeah, let me just see if there's a toStr into string or as str. If there's a trait for this specifically, but I don't think so, no. They used the last minute chance to basically use as ref for all this stuff, which is really what you want. It's a generalized form of it. So yeah, now we can just return this and we are good. You know, that's already a valid string slice here. Voila. Cool. So now this should work. Wow, it does. At least as far as we tested. And now we can, you know, basically what you see here is the code needed to do this. So in that regard, you know, this is kind of very orthogonal in a way, because you implement each trait specifically, so it's very nicely separated, not nested. I kind of like that. I can also live with this inline implementation. I kind of like that too, to be honest, even though it's in every way more wordy because you have to use return statements everywhere. So code-wise, you will, I mean, there's no doubt about it, you will write less for more. So we have a struct comp provider, and we have a struct armed provider, and now it's really copy paste business, which is annoying, but it's just for the example, right? So that's a complementary service, and this is a comp. Actually, I know it's comp service, of course. Comp service. And here we have armed service. There we go. And we are done with that one. Now we go ahead and do the armed service, which is armed and armed service. Thank you very much. So now we have the default service, and the interface that we have here is already better than this one, because we will always be sure that if there is a services singleton, I mean, we have to pass this around, right? There's no global stuff in Rust. That's a good thing for every program. Yeah, so now I think we are already better. So now we have to make a new instance somehow. And there is this new service. I would call it default service because it's a static, basically it's a type method here that returns the standard one all the time. Actually, the implementation for this is here. And yeah, so let's do this implementation. Now we need our own instance, obviously. So we have fn, how do we call it? We could call it new instance. We could call it new by name or service by name, but this is a services by name. I think that's better here because this is what we do. This will not change ourselves at all. And I wonder about mutability here, because this stuff is mutable. It's static, but it's not const. And I think if you don't specify it as const, it's mutable by default. Yeah, so basically everything is mutable by default in Java, which I also dislike, but that's the case in basically all of the languages that you have. Anyway, so that's the name here that we want to provide. We just need a string for this. And you could say, well, you know, why not string? Because, you know, people might just have a string slice, which is has a static lifetime because they know the name at compile time. And Others might have a dynamically generated heap allocated string, and they can just easily do an asref str here. And just to make it so, let's say, yeah, we need an asref str, because then we do the conversion and people have it easier to call us. You will see what I mean in a moment. So the result type is quite important, because this guy throws here, and it's an unchecked exception. It's unclear that it can throw. And considering, honestly, honest to God, considering the only purpose of that thing is to produce new instances, then I think this error handling is terrible. Terrible. Because, it's so easy to not have an instance here. And it's not even documented that, it's throwing an illegal argument exceptions. Terrible, honestly. And this is in the book, right? And sure, this is only my opinion, and I'm not, I don't even bitch about anyone in personal, but if you have done Rust a little bit, then you know that this is not good. Checked exceptions are probably what you want here, to have some sort of documented and compiler enforced safety net built in. So we have a result. I just, take a normal result here. And yeah, let's see what's the cheapest way to implement an error here. I don't know about the error type yet, so I just specify a unit here, which is like void or null or nil. So that seems acceptable, but I shall change this type soon. So yeah, this basically now says, well, it can fail, but if it works, you get a service. Otherwise, you don't. Let's see how this is implemented then. So we want to do a lookup in our array. By the way, how far do we get? So if I return an error, does this work so far? So asref. So this, this is true. This is now actually a generic, we can provide a borrow to an asref. Then we don't need to know the compile time. Then basically it's hidden here. This is fine. But I think, let's see how we can use this. I would be totally fine not using a generic method here, because if we would do that, then we basically have one method per input type, which is also fine. I mean, what can happen? It can be a heap allocated string. It can be a string slice. So it's at most two methods that we generate here. That shall be fine, but I would like to try it with a borrow. Let's see how that feels. So let's see how that feels right now. Services. Let's call it service then, because that would be nicer. Service by name. And I just hand over foo. And then we can say assert equal. This is definitely supposed to be an error because there is no foo. Right? Let's see if this works. So this is how I want to call this. And also, this should work natively, because this is in a heap allocated string now, foo2. And la la la. And I think this doesn't work because of that thing here. So if we put in a type here and say where s is an asref string, then I think this will work just fine. No. Okay, so there are two things here. Actually, maybe it has been working previously as well and I wasn't looking at the right thing. Because we have a... No. Okay, so that error is gone now. That problem is gone. So yeah, we need a generic type here, or we need to get the borrowing straight. And I don't, would be interesting to see how that would look like, but probably it's not as comfortable as what we have here, because this is what we wanna achieve by doing it the way we do it. I'll put that here, kind of. I'm always wondering how I best format these things to make it as readable as possible. Yeah. Okay. So the problem now is that a box service can't be debug printed. And it wants to debug print it in the moment we use assert equal, because if it isn't correct, then it wants to print the result basically. And if it wants to print the result, then you need to implement debug. So we could try to do that here, which should even work, right? And this is kind of standard stuff that you always want. So of course it must be implemented for service, and then it's also implemented for the box and stuff. So let's do this. Oh, no, wait. So debug must be there as well. Does this work? Debug is not here. Use std debug. No, std fmt debug. I think here it is. So now we specify, well, we need as ref, and we need debug implementation as well. And guess what? Now it tells me that debug is not implemented for these services here, but we can auto implement this, fortunately. And now we go with derive debug. And we should be better. No, is not implemented for this function. Terrible. I think we should be able to implement it. So we don't have to implement it for the box FM, but we can implement it for this one, because box will inherit debug if it's implemented for the contained type. Yeah. So again, if you would just use assert here, which doesn't trigger a debug print, we wouldn't need that. And honestly, I prefer that. On the other hand, let's go all the way and see how it looks then, huh? So let's implement debug for our function, for our closure here. So impl debug for this type. That is totally fine. So we implement it for the closure. And I think it's fn fmt. We get ourselves, and we get a formatter which is mutable. And we shall return a format, an fmt error or something. Now I have to look it up. FMT. That's... Can I get the function? Debug FMT, here it is. So that returns a result. This result is a standard one. So it's a result, and this error is an FMT error, huh? Yes. So I guess... let's get self here as well. So I get FMT, the FMT module, and now I'm able to specify this results. If it works, there's nothing in it. But if it doesn't work, we have an FMT error here. So that's just for the signature. The cool thing is that I can now just say I can now just have a string here, say constructor, that returns a box service, and I call FMT on it and pass on the formatter, and we are correct, which is an FMT formatter now. So this is how that works. Because I know that the debug trait is implemented for the standard primitives, basically, I can just call it here and say, well, the return value of this call is exactly what I want to return here, and we are good. So now I should be able to do this. So, a box service cannot be compared for equality. And that is true, you know, it tries to compare the result, but result only implements comparison if we have this implemented for the box type. And interestingly, this should always be, you know, comparing these is not easy. It's difficult. And because you then have to compare the actual pointer to the function. I don't know how that works. Because I could easily register the same constructor multiple times and box it. So just comparing the box location itself will not be doing it for me. So yeah. All this for assert equal, I'd say I could either implement partial equality. Let's see, maybe we can implement it automatically. Maybe this will just work. But probably not, no. Also, I can't auto-implement this. So what does it want? It wants basically partial equality or equality. And I wonder, you know, we are already nearly an hour in partial equality. And we are not yet done. Let's see how much work is needed to get this to work. So it's just this one here. So the thing is, we have to implement it on the box type itself, because this type here is a different one for every function, for every closure that we pass in. So we have to compare boxes, and as I said, this doesn't really work. We could only compare the box itself. And even there, I have no idea how this really works, even though I can probably figure it out. So I would probably say, yeah, it's just false. It's not equal by default. Yeah. So it's always false. I think we could do this. Gee. But in a way, we don't care. Can I just take this error here? You know? Because then I don't have to do this. So then I can also just remove this thing. And we are good. FMT I don't use anymore. So I can roll this back. Yeah. So I'm just expecting an error here, and I expect that this error is some error. Like this. Nah, come on. And here it's the same thing. So I'm now extracting the error explicitly, and I expect it to be something. And this is now working, I think, provided I get all my parentheses, right? Yeah. Still wants debug. Yeah, we just removed this implementation. And why does it need it? Ah, damn it. Yeah, so we need debug because we require debug for the services thing. And I wonder if we really need that anymore or not. No, I don't think we need that anymore. So let's kick it out. Yeah, so that should be fine now. Soon. Oh, yeah. We have specified it here. Now we can remove this as well. And we're good. Nice. Finally. So, now let's implement this by name, shall we? Yeah, I don't know the hash maps interface by heart, so I have to look it up real quick. So, entry we could use, get we could use. So get is really what we want, and get is what we will have. Let's see. And how this will work out as well, because we have to return this thing. And now we have to deal with lifetimes too. And this box, by the way, is a borrowed box, right? And right now it is an owned box, which we will not get, we will return a borrowed one. And I also wonder if our constructors are too, we could enforce f and mut. And I don't have, because now I think fn cannot change anything. It cannot change state, its own state, which might be a problem if you want to count certain things. Yeah, so I think f and mut is probably what you want to do here to be a bit less restrictive. But we'll figure that out. The cool thing is, well, you have to think about that, right? So yeah, let's do a get here. Self providers get on the name. Let's see if that does anything. Then we will get an optional. If we have some reft constructor. Oh no, wait. Actually, that's all right. That's totally all right. We were saying that we create a new service. So it's totally all right, actually. Let's see. I think we have to ref it, but maybe not. I will just wait for it. Actually, it's more like this what we get, but let's see. So in this case, we just call the constructor, right, and get a new box service, which is exactly what we require here. And if there is none, then we return an error. For now, it's just this thing. And that is that. So that should be our implementation. Considering, yeah, no, I think that's that. That is what we need. So let's see if that works. In the sense of if it compiles. Okay. So here we have s. Sure, as I said, we have an as ref here. So in order to get anything that matches, we have to call as ref, and then we get an as ref of the respective type. And yeah, let's see. As ref, and that still is not enough because we get an as ref str, and this guy wants a reference to a string here. A heap allocated string. Oops, I didn't save it. Ah, that actually did work. Cool. I like. So that's cool. That's very nice because we don't heap allocate anything here unless we have to. Actually, we never heap allocate something just for the purpose of accessing the item, which is awesome. So this is why you probably want to work with as ref here all the time, because that will be much more efficient. So attempting to move out of this, I have seen this coming. If we do this, it works. Okay, so that's automatically a borrowed constructor. We call it and we are done. So that's the implementation. Let's have a look at the implementation here. Here we say get, and then, it's a provider reference if this is null. So you do null pointer checking here. Then it's, we throw this exception which is not documented, and otherwise we make the call. Interestingly, this is, whenever you see this, it could always be null, right? This is what I assume, because this provider's get returns a provider, which can always be null. So this is also not documented. It's in Rust, you would have an optional or something. And an optional says, well, it's either there or not, and you have to deal with it. Here, you could easily try to access this null pointer and get a null pointer exception. Gee whiz, I do not like this. Okay, so here we go. We could also assert that we get a service. A default service. Yeah, let's try that. So assert equal, service. And let's get the default service. So let's have another function, default, which takes a self, returns a, and this is guaranteed to be there because we definitely have a default provider, which is definitely returning a box service. And this is definitive, right? So if any of these constructors would not be able to produce a service, then you would have to panic. This is nothing that is allowed by the interface. So basically we can just throw it here. Yes, we return a box service all the time. And there's no question about it. So all we have to do is say, well, self by name. Now we just drop in the default provider name. And we unwrap this thing. Unwrap can panic if there is nothing in there, but we assume that there is something in there. If that's not the case, we will panic here. Fine. But this is not expected by how the program is made. And even if something goes wrong there for some reason, the program will abort properly. Unfortunately, this unwrap here, it requires debug to be implemented, which right now we don't have. But so basically this might not compile for that very reason. Oh. So yeah, let's try that first. We have default. And then we say as ref is default service, right? So this is what we would expect here. Yeah, so look at all this type inference going on. As ref is calling this implementation and it knows it needs a string because on the right side is a string, str, right? And this is super awesome. You never specify types unless you have to. And there is a minimal amount of redundancy, if any. So that's totally awesome. So yes, this already works. And it's really nice. So the unwrap is done within our own interface because we know this is working. So this one here provides a guaranteed default service. Okay. And what else is there here that we need? Yeah, we implemented it already. Look, our interface is simpler. We just have default. Oh yeah, we still need to be able to register something. But we don't need that one at all. So let's have a register constructor somewhere. fn register constructor. Yeah. So with our terminology here, I think it would be all right to call it a register provider, huh? Provider, it's a mod self, because we are going to change our own state. Then we need a name, which shall once again be an sref kind of thing. And we need a provider, which shall be a generic again, because otherwise you would have difficulty specifying this, or you need to box that thing, and we don't want that. So we have S and P here, and you can see in Rust using generics is just part of the daily business. It's nothing special, not at all. And yeah, what can happen? We are not allowed to override an existing one, right? So we will not override providers ever. What happens here? What's the behavior here, by the way? Put. Okay, so we will override this. Good. This will always work then, huh? Totally. Let's see if our interface of the hash map with insert represents this or reflects this behavior. Yes, it does. Inserts key value pair into the map. If the key already had a value present in the map, the value is returned. Otherwise, none is returned. So we could do the same thing here. So if you override a value, then we will return the previous provider, right? So yeah, and it returns ownership back to this one. So we have an optional, what is this? A constructor, an optional boxed fn. And you know what? Let's do this now. Type constructor is this. And we say, well, it's a closure. We need to box it anyway. So let's do it, because that will be so much more comfortable. And I'm sick of specifying this more than once, that's for sure. So here we have the default provider, where this is, oh look, now I kind of want the unboxed one again. Yeah, so let's make it a boxed constructor. Like this, and now I can say, well, it's a constructor. Like that. Do we specify fn anywhere else? Yes, here we do. Boxed constructor shall be returned to you. Okay, cool. And now I think all we have to do is to make the call. So it's as simple as this: self providers insert name as ref and provider. Obviously we shall still have to specify what we need here, where s is an as ref str and p is a constructor, and doesn't like it for some reason. But why does it not like it? Probably, I mean, maybe something with the syntax, huh? That's usually something I get wrong. Constructor is not a trait. Yikes. That is true. But excuse me. Oh shit. I messed this up. So now this doesn't work in two places here. True, you must specify traits. How can I do a type mapping then? Rust type. Because the fn is a trait, obviously, and I wonder how I can make this easier for me. Huh. Closures. Show me, is there a type def possible here? No. Huh. That's weird. Okay, good. Yeah, forget what I just did. Then I have to roll that back, I guess. So this works, but here doesn't work. Unless I say I want a reference, a borrow to this, then it will also work, huh? So maybe we do it like this then. Let's try it. Let's try it real quick. So we want a borrowed constructor. And yeah, no, actually we don't want to borrow off this. We want to own it, right? So either we have a static, yeah. So would this have the required lifetime then? No, now we would have to do it like this. And this would change the type that we have here and change a lot of stuff around. No, I don't like that. I might explore this another time. But for now, I think there's no way around but to just spell it out all the time. Well, fine. Here we go. Here we go. Here we go. Interesting. That is kind of fun to do that. Here we go. And that should work, huh? Kind of. Oh yeah, true. Now we have to convert it to a string because this requires ownership. And well, we can also say to owned, which shall work just fine for us. And the P, it wants to be boxed. I always forget that. Box new. Fine. And maybe it wants some lifetime now. Yes. And there we go. Cool. So now, in order to complete the test, we will just have to register these providers by their name. And we can do this actually. I mean, these are all instance methods here. So we will. Yeah, how do we get a static name for that? I don't think there is something like it at all. Not right now, at least. Unless we say a service should have a name. That would be interesting. And I would kind of like that as well. Because then we can make this implementation or automate this implementation even. Oh. Let's explore this. Okay, so I would like to have a name method because I don't like to have these globals. To have it made like this. Just magic values. To me, that's magic values, and you should avoid these. Either you have constants, but constants are so detached from their actual type. So what if you have a name method here that returns a static string? So what about this? So now the service needs to implement a name, which is something we can nicely use later. And the default implementation, no, we can't do a default implementation like that, but we could have a standard implementation, I think. Impulse service. How would that work? For all types that have as ref, huh? For T where impl T. For all T's where T has an as ref str, because now we should be able to say, well, fn name. Oh shit. Damn it, we don't have an instance here. So we can't call as ref, so forget that. Damn it, you. Yeah, so we didn't win anything there, but I think we can turn it around. So we can implement as ref str for service automatically. I think this is what we can do. And then we don't require it anymore, because now we can just say, well, self name, right? So this is our own type, whatever it is then, and we make the name call here and get a string. So that should work. And now we can say, well, we implement service for default service, and now just have to provide a name here, which is default service. And we do the same for all the others. I think I can just, oh well, let's copy it like this. So that's comp service. Yeah. That sucks. But that makes it actually less redundant. I like that. Should have done that from the very first beginning, but I haven't seen this coming, to be honest. But here we are. So yeah, we're kind of gently forced to do it right. Just by the way, you know, just because Rust is Rust, I think. Just because the language is what it is. So implement service for armed service, and there we are. Cool. So that is that. That should work as it worked before. And makes registering much easier. Cannot be made into an object. I think what we have to do for T, where T is a service, so does it like that? If I would get the syntax right, it would certainly like that. Cool. So now we have a generic implementation and auto implement this for all services, right? Must be used as a type parameter for some local type. MyStruct T. Only traits defined in the current trait can be implemented for a type parameter. So how do I implement this for a trait? How do I do that? Yeah, so that T is, well, it's actually quite narrow. Huh. But yeah, for T, where T is service, where's the core implementation? Nowhere. Doesn't show it, unfortunately. Damn it, you. 1 hour 22. Okay, so I should probably get done with that soon. Maybe now that I have a name, I don't need asref anymore, but I would love to implement asref by default here. How do I do this? For service, it doesn't like because it's not a structure. If I require asref, maybe then it kind of makes it work. Nope. Type parameter T must be used as a type parameter for some local type. Yeah, well, if that is the requirement, then I can't do it. And this also doesn't work. We tried that. Nope. Because service cannot be made into an object. Is not implemented for the type default service. Yes. Sad. Well, I think then as ref we have to kick out here. Yeah, we have to, I guess. That would be cool. That would have been cool. That would be my intuition. And now interesting. Method name has no receiver. Oh, now we don't have as ref here anymore. Default name. I should be able to call it like this and get it anyway. Yes. Huh. Excuse me. So I've lost a lot of capabilities, even though there is no type here anymore. And I nicely implement service for my structures. What the heck is going on now? I would like to have to make this work right now. Like right now. So that's done. That kind of works, huh? Cannot convert to a trade orders because trade service is not object safe. Damn it. Why is it not object safe? Yeah, so that might just be a follow-up error because of this, huh? That probably is a syntax error. Yes, it is. Huh. Why are you not object safe then? I would love to. Also, is it valid to call a type method on an instance? I can't remember having to have done that ever, I think. So how do I get that then? And why is it not object safe anymore? What does it mean? Can you explain this? Rust C explain E0038. No. So I'm sure there is an explanation for this on Stack Overflow. So the problem is that, as the error message says, that the trait is not object safe. That is, it is not safe to use that particular trait through a reference or a box. Specifically, the does something method takes self by value. Consider how does the compiler call this method on a cont that has been placed. Yeah, it has to call. Yeah, but I don't do that even. Or generics cannot be used via reference. I know that. But why is it not object safe if I have a name here? I mean, what the heck? This is just standard, right? I could take self here, obviously, but then it would defeat the purpose, because I wanted to be able to get a name without having to instantiate the type explicitly. Damn it, you! But maybe it, maybe that's just it. It's this bloody name. Damn it! And I would basically need an asref again to make this work. Huh. Interesting. I've actually never tried that before. See? And now it tells me I can't do it. Ah. That's annoying. I could obviously have such a method on all of these in just their own implementation. And probably that's how I will do it then. So yeah, forget it. As ref, I don't think I actually need. I just need to be able to make that call in order to yeah. So let's try that. Let's try that. Impl default service, they all have the same. They're known at runtime, so yeah, fine. So does it work now? Oh yeah, sure. Now I have to impl service for default service. Now I have to put that again. A lot of back and forth here. Ah, damn it. I should have seen that right away. Yeah. But it's good that it doesn't allow semicolons where they're not needed. It's a great thing. And name was not found on box service because, yeah, it doesn't have it, right? Right now. Yeah, I could enforce. I have to get some ID on this thing. So now I could enforce as ref again. And then, you know, stuff starts to repeat itself. So yeah, I need as ref string. Now I need to implement it. And I wonder, can I default implement as ref? No, because there is no trait that specifies. No, it doesn't work. Ah, damn it. So now it's all repetitive code. I could have a macro for this, huh? Yeah, I think that would be what you want. Oops. So macro is impl as ref. Oh, damn it. So that's a mapping from basically a certain amount of input parameters to of input parameters to whatever it should expand to. And that's all cool, but I don't know, that's the type or something? Yeah, let's look it up then. I'm not fluent in this. Macros, but you know, a simple type I can take here. So, please do it now. Oh, it loaded already and I didn't see it. Here it is. That's an expression, so that's how it works. Type. Macro by example. Oh, really? I think there is some stuff by example here as well, or maybe in the Rust reference. Macros, oh, look at that. Macro rules, macro by example. So what can you do? Idents, types. I think identifier, huh? That's what you want. Is that all? Expressions. I've seen documentation about this. Item block statement here. I think this type. That's what you want. Type is type. Yeah, and then it's more like that. Oh. X, Y. Ah, so that's also an us structure that you can have. But anyway, in my case, I think all I have to do is type T, and then I can just make the implementation here. So as ref impl as ref str for T, and then we have as ref with a self return a string and say t name. Actually, we can do self name here because that should resolve to the right thing, and we're good. Yeah. Let's see if that works, but it should. And that's one way to get around redundancy. Impl as ref for default service. Yeah, I can also do it here for default service. Yeah, let's do it where it happens, where it's required, for comp service and for ARM service. Now we can do as ref, and it works. Awesome, my first silly macro. And yeah, all that just to register provider and non-redundantly implement or get a name that we can call on the type itself. So let's do it. Yeah, so this should also always be none, right? Register provider returns an optional here, which is the previous value that we have seen. Yeah, so that's just an assert none or is none. Assert service register. You know, what about add provider? This is what we do. Add provider, then we need a name, which is, for instance, comp service name, and a constructor that creates a comp service. Box new. Yeah, the question is, can we make this nicer so that we don't have to box this stuff in the return value? No, because then we would need a generic method. No. Okay. Box new, and we return a comp service. And this should be is none. Good. And now we do the same for the ARM service and drop in an ARM service, and the result should be none. And if we put in the same one again, then we expect that we get the previous value is some. I mean, it's kind of superfluous to do that, but we should do it just to be complete here, right? Cool. And that also works. And now we can do some instance creation here and say, well, service by name. And then we give it a comp service name. Is supposed to be some, right? What do we return? Return a result. Is okay. Yeah, we can just unwrap this basically, because we expect this to be there. Then we get the value. We say, well, convert yourself into the service name, and then we expect it to be the comp service name, right? This should work. Voila. And the same goes for the other service, the ARM service. And I wonder, I do wonder if we can loop over this. Probably not. We cannot abstract types. You cannot loop over types. I don't think this works. No, not here. Not in a statically typed language. Not like this, at least. All right. So here we go with the ARM service, and again ARM service. And that should work as well. We don't need a mutex, we don't need debug. That is true. And we are done. Well, that was 1 hour 40 minutes of getting this to work. So that's basically the registry. But I think the interface is nicer here in Rust, even though there is more, let's say, more visual noise, right? Because of the generic stuff that you kind of naturally use here. One might ask if it could be possible to, in some cases at least, get rid of these and just use borrows, which you can, of course, but then it would make it harder to use for the user itself. So APIs usually benefit from generics because it makes it really easy to use on the client side. And personally, I prefer that because there's just one U, but like 1,000 clients ideally. So yeah, I see. It's interesting to see this difference. We also were able to just drop it into one file, but I think just by using what we used, or by doing what we did, we improved. Or by using Rust, we improved the API of the entire registry and made it safer and better, because this one can so easily be misused here. And yeah, so I think before I close this, I want to really have this test module just to indicate this. And actually, in order to remove visual clutter, let's do some fine refactoring. I would like to make it real. So that's our library, that's fine. This is now a public trait that will be exported. This is something that we don't need. This can be our internal knowledge. And it should never clash, right? So in a way, we want to make it very unique. And this is also public. And this is it. So now let's have a test, an integration test. That for now is kind of a unit test, but I like to drop it into a different file anyway to separate it. So let's call it unit RS because that is like our unit test. And then extern crate. Let's pull in the library. Item 02, item 01, right? That's what it is. Cargo TOML, item 02. Really? Oh. It's item 01. That's a bit better. And yeah, I might want to reopen them. Lib unit. And that's the code. So now it's better separated. Quite a lot of code here in Rust to get this to work, because there's no in-place definition of this stuff, even though you could, if you wanted to, put these implementations here. This will totally work, I think. So yeah, what do you say? Extern crate, it doesn't like extern crate? Why is that? Cargo test. Use item 01, and then we get service. I don't know why it doesn't like the extern crate. Maybe I'm brain fucked again and I can't find crate. Can't find crate, really? Let's see. Service and services. All right. True. We messed up our interface by not doing what I do now. Right from the start, in the sense of, okay, these need to be public, obviously. And it works. Test unit. So now we only run the unit test. And this works. Awesome. So that shall be that. I like it. Even though I'm always thinking, damn it, the formatting should be better here somehow. So yeah, that is that. Thanks for watching and have a great day.